this workshop is designed to do is using local professionals to talk about things that don't get commonly talked about necessarily. So the panel here, consisting of myself as an architect. I've been practicing here for 39 years, and 3 or 4 years before that out in Michigan, in all areas of energy and the like. Am I being heard okay? Okay. I've been involved with the energy movement and such for a long time. If you remember, we had sort of an energy crisis back in the 70s, and I got quite involved in that. So to my right, I have Laura Intscher, who has been here 8 years or so? 10 years. Transporter from California, working for any number of firms there, and has had, I could say, probably a lifelong interest, but certainly in her career, extremely interested in ecology and conservation and what we currently talk about as green and the like. She was raised in northern Canada and brings with her the Canadian perspective, I suppose, on sustainability and the like, but still she's unique. Laura, as a lot of you might know by reading articles in the paper, designed and had built her own straw bale home. It's up by the BU campus, and it's an extraordinary house. She's also done for others, and she'll explain that. In her presentation, she'll be discussing, as she puts it, how to get green without getting taken for a ride. She'll also talk about greenwashing, in case you weren't familiar with that term. To her right is Madeleine Cotts. Madeleine is a licensed landscape architect. She works for a local firm, Berescampo Knudsen, of architects, engineers, landscape designers, and so forth. Lots of experience in this field, as well as general landscape architecture of all sorts. She'll be discussing sustainability relative to sites. And you might tell by that, we're talking about sustainability, not just buildings. Just happens to be the topic, but the idea of building design has to incorporate everything within the borders of that complex. The property lines, you might say. So she'll speak to that. And to her right is Dundon, who's a local insulation contractor who I've known for a long time, and of all the varieties of people I have known in the construction field and these 39 years, I cannot think of a better representative to talk about sustainability and green in the construction area than Pat. He owns what's called the Insulation Man. So he's been doing this, the insulation end of green and sustainability for 20 years. He has self-educated himself beyond what most any contractor would to try and stay on top of the latest technology of anything to do with insulation. I'll just quickly give you some credentials, which you won't necessarily understand what these even mean, but I'm not going to try to explain it. He's a BPI heating specialist, a HERS rater, NAHB green verifier, a ResNet green rater. All these are credentials that he's sought out to become better in his own field. His degrees from college, interestingly enough, are in meteorology and oceanography. It's a good background. He's going to be talking about how insulation works, how the consumer can be more proactive about making use of insulation techniques. Wants to talk about code houses, how he sees some code issues, and how a home acts as a system. I want to set the scene a little bit, try to get through this kind of quickly. The history of green building of sorts. Many of us kind of know the progression if you were around from the 70s on, not knowing the audience, just in case we had too many young people, they need to hear some of this. And I wish this room was filled with young people, but that's another story. 1962 was a consciousness-raising event that happened by an individual. And it speaks to what one person can do that affects the entire country. Her name was Rachel Carson. She wrote a book called Silent Spring, and it had to do with DDT. Perhaps if she hadn't done that and started a campaign to get rid of DDT, we may still be using it. It's that sad. So that raised environmental consciousness and the effect for all of us in the whole country. Then I've got to jump here to Jimmy Carter. 1973, he proposed the Department of Energy. And it had to do with the first energy crisis that happened in the early 70s. 1974, the International Energy Agency was established worldwide due to that oil crisis. And that particular agency promoted alternative energy. So this is nothing new, is the point of this. Alternative energy has been talked about well before the 70s. That goes back to the beginning of the 1900s, if you actually look at the history of it all. 1977, I don't know why, but it took 4 years for Carter to actually get a Department of Energy established, which, sadly enough, after his administration, faded away from energy conservation. But that's another story. 30 years ago, this month, April of '79, OPEC raised their oil prices 14%. 2 months later, the Shah of Iran was deposed, and OPEC decided, well, what the heck, let's raise it another 15%. And that's what many of us remember. The lines, the gas lines and oil embargo and all that sort of thing. That a substantial amount of the community, because of their energy bill at home and their gas in the car and so forth, were awakened to the fact that maybe there is an energy crisis on this planet. The sad thing is it lasted about 3 years and then everyone forgot. Many people forgot, sorry. By '81, in other words, OPEC said, whoop, this is not a good idea, and they reduced their prices. In the meantime, there were, banks were loaning money at 22%, and in case you didn't know, there was another economic crisis back then. 1990s saw the growth of the green movement and the development of the U.S. Green Building Council, USGBC, some of you have heard of, substantially because of the involvement of an architect, and his name was Bill McDougall out of Virginia. And he said this is necessary, and he and a number of people said this is going to happen, and it did. He's still one of the prime movers of green in this country internationally. By 2000, the International Building Code was adopted over the entire world, including energy. Also about that time, an organization called LEED, L-E-E-D, Leadership in Energy and Environmental Design, was established. Professionals now around the world are gradually becoming LEED certified. And when I say professionals, I should extend that to the fact that anybody in this room could be LEED certified, which is to say you would learn pretty much all the current information on energy and the environment as we know it today. Just pass a test and you'll be certified. 2003 saw another landmark by another architect out of Santa Fe. His name is Ed Mazria, and he started 2030. And he's convinced that if we don't do something reasonably fast, this planet is in pretty serious trouble. So if you check the website, plug in 2030, it'll come up. You'll see a phenomenal amount of information on what's happening around the world environmentally and so forth. He's the man that wrote the Solar Handbook back in 1975. So he's been very active ever since. And then I jump up to 2008 with Mr. Gore. And if you check out Al Gore's kind of biography, when he first got in Congress, 70s or so, he was pushing this agenda back then. It took that many years to get people to listen to him. So with that, I introduce Laura to start us out. And thank you for coming.
My company is Secret Based Design. And I am an architect, certified, and I specialize in green building. So why are we here? What's really wrong with what we're doing? It looks like a beautiful house. Actually, I designed it. What's wrong? Well, construction, remodeling, building demolition, new construction account for a significant amount of the material in our landfills. Probably on average about 40%. That's 40% of the trash in our landfills is directly from my industry. This is an embarrassment to me. We have to change this. Buildings account for more than 50% of the fossil fuel consumption. It's not often talked about. Talk about hybrid cars and saving gas, but frequently the worst offenders, our buildings, are not in the equation. The building products that we're using, things that are manufactured today, they create health problems, indoor air quality issues, and future ecological harm when disposed. Our buildings aren't recyclable. They aren't made of recyclable materials, and they're not made to be recycled. Construction is considered disposable, maybe for a 40-year lifespan. We rarely also use local products, local labor, local materials, local craftspeople, and because of that, spending a lot of energy on shipping. So I guess there's a problem. How do we build better? How do we build green? What is green? Green is all over the news. Greenwashing. Green in every advertisement you see. How can we evaluate what green building really means? Well, one perspective is really green is a very small footprint, a very organic structure built by the owner of materials found on the site. I don't think this is a sell that's going to work for most Americans. For some it does. So instead of that, how about we beat the problem over the head with technology? Industry, we have lots of industry. Let's solve the problem with brain power. New materials, new equipment, new systems. But I think that there is a balanced approach. This is my home. And in my home, I try to incorporate not only high-tech materials, high-tech energy systems, heating and cooling systems, but I also used straw bale construction, going back to kind of a low-tech construction method in combination with technology, using the better choice when it presents itself. Balance, the big picture. When I analyze materials or a system or a building, what I'm looking at is I'm looking at these elements primarily: location, material, manufacture, lifespan, use impact, and disposal. Location, location, location. What's true in real estate is true in the building field. If you can get it locally, if its source is local, if the production is local, if it's warehoused and shipped from a local area, that is a better material than another material. I won't say it's a green material because maybe it's not completely green, but there is no green material. There's pluses and minuses for everything. So here's two examples. Straw. Straw, I guess, is probably for me the most perfect green material that I have used. It's sourced locally. Production is minimal. It's a waste product of wheat production. It's usually not warehoused. It's usually just delivered right to the site. And the shipping is minimal, and it's a lightweight material. Another example is my door. I found a beautiful door from a catalog from a company in Florida. I do not know where the wood was sourced for this door. I loved it. They couldn't deliver it to me in time. I found a local woodworker who built the door from local lumber, harvested responsibly, and the door is insulated, higher performing, and guess what? It cost less. Proving that green, what you've heard is not necessarily true. Green is not always more expensive. Some things are, it's true, and some things are not. But if you look at the whole package, it balances out. Material. What is the material actually constructed of? Is it a natural material, such as wood? Is it a synthetic material, such as vinyl? Is it a combination, as you might see in a window system? Is it recycled? So here we have a few cases. The blue stuff there is cotton bat insulation, natural material, and a recycled material. Then you'll also see the next picture down from that is also insulation. It's a combination material. It's made from soybean oil as well as synthetic products. So again, it's a combination. And in this case, the steel is recycled and continually recyclable. Synthetic. I don't tend to like synthetic materials, like vinyl, but there are some synthetic materials which are very, very eco-friendly, such as recycled polyester carpets, which can be produced in a closed-loop, cradle-to-cradle system, which makes the carpet back into carpet, back into carpet. So in that case, synthetic is good. High-tech solution, in that case, is good. And in the case of natural, some things may be good, some things may not be good. Granite countertops, yeah, they're natural, but they are mined in India or Brazil, shipped to Italy for finishing, shipped to America to be warehoused and finished, and then shipped to your job site. Natural material? Yes. Eco-friendly? I don't think so. So everything has pluses and minuses. Manufacture. What is the impact of the process of that material? What is the embodied energy in the material? And is it recycled? So in the case of the log cabin, we pretty much know what the embodied energy is to grow a tree. Now, is it also harvested responsibly in a forest that's managed? The adobe block production, that is extremely low embodied energy, and if you're doing it yourself, you know exactly how much embodied energy there is. There's also little embodied energy getting that product to the site. And in the house, there's a combination here. There's a steel roof, higher embodied energy, but because the walls are steel, or because the walls are the straw bale and the lumber for the frame is local, it's a trade-off. Lifespan. What can you expect the lifespan of the product that you're using to be? Is it something that's very long-lasting, high performance? And if it is, can you minimize the replacement and repair of the components? If we're constantly buying materials that wear out, we're not doing much good. So in this case, I'm showing two high embodied energy materials, the steel roof and a concrete floor. But in both cases, these materials will last a significantly longer time than an alternative material would. And so it makes the embodied energy maybe a little more tolerable in that system. Use impact. What is the energy used? And I'm sure we'll hear more of that when we hear from the insulation man. What is the energy used? What is the health of the occupants and the comfort of the occupants? And what are the maintenance constraints? So in the small house that you see, it's not made of green materials. It is highly insulated with an energy efficient furnace. It has a very small footprint. I would consider this a green building, even though it's made of conventional materials. And energy use over the lifespan of the building is actually a much larger cost than the initial structure. If we get the initial structure right, it's continual savings for years and years and years. You can also see in the slide beside that, passive solar system. That's another way to reduce energy use. And again, beside that is a masonry furnace. It's a furnace that stores energy in the mass in the same way that solar works, storing the energy of the heat in the mass and then radiating that out. And finally, there's a slide, a partial slide of part of my geothermal system. And that, again, takes the energy from the sun that soaks into the ground, keeping the earth at a constant temperature at a depth in this location of about 5.5 feet. And then the energy from that powers the heating and cooling loads for the house. The combination of the geothermal and the passive solar and the masonry furnace, I discovered this winter, is a very, very good combination in a straw bale, well-insulated house. Our heating system went out for about 10 days. The drop in temperature after 10 days was 3 degrees. That's when we first noticed that our system wasn't working. It took another week for the repairman to get there, another drop of 1 to 2 degrees. That is a pretty functioning system. Oh, and that was in January. So a total system can be very green, but you got to think of all the components working in combination with each other. Disposal and recycle. What will become of our buildings? The top slide shows a loft renovation in downtown. And the huge pile there is going into a dumpster sitting out front. And I'm sure we've all seen the dumpsters in front of construction sites and demolition. At the construction of my house, I did not have a dumpster. I had no need for a dumpster. This is unheard of for building. Below that is a block called Durasol. It's a wood chip ICF with concrete and mineral fiber batt insulation. What if we could take the wood from that top project and cycle it into the factories that produce the Durasol block and get that system working? We also need to look at how we can deconstruct buildings, especially our old buildings which have beautiful features, and reuse them directly into our houses. And the last picture there shows an innovative use, direct use of an item into a building. The most simple recycling you can do. So in general, we want to reduce the use of extra materials and products. We want to use long-lasting materials, recycled, reclaimed, regional or American-made products and materials. And in these two examples, one on that side, there is no ceiling. So there's no materials and there's no labor to build a ceiling. Do you really need a ceiling? And on the floor, concrete floor. You pour the concrete slab, you're done. No carpet, no installing, no trim, no labor, no extra cost. Green can be cost saving. And the other slide, the kitchen slide, the tin ceiling is actually a reclaimed from an old building. The fixtures and appliances are American made. The countertop is made of compressed paper. It's 100% recycled, compressed paper. And the structure surrounding the kitchen is made from sunflower seeds pressed again into a board. There's lots of these materials being made in America, very innovative, and you got to kind of do a little digging to find them because many of them are not manufactured by the biggies. So you have to do some research on your own. They are not appearing in national magazines. So in closing, we have to balance the positives and negatives. In this slide, I like this slide very much because it does show the contrast very well between the steel and the concrete block, again with high embodied energy, but the very low embodied energy of the wall system. Fluorescent lights, also. And all of these products are regional or local, and that also supports the economy and the jobs in our area. Here are some of the organizations that Jim had mentioned, and I have some disagreements with on the LEED, how well that is working. I think that these are minimum standards. They're a good starting point, but we need to find solutions beyond what they are allowing for. LEED doesn't allow a lot of points for things like straw bale building. There's a lot of other types of buildings and systems that would work great for being more green, but they're not recognized by these organizations. Take the information from them, jump off, and go beyond. Let's go build green now. Thank you.
Hi, good morning. I'm Madeleine Cotts, and as Jim said, I'm a landscape architect, and I also feel like I have to make a confession, which is that I'm a LEED certified professional. And I agree that LEED is just a start. The other thing about LEED that a lot of people don't realize is you don't have to be a LEED certified building to be a green building. That LEED is a system of verifying and doing a lot of paperwork to make sure that you've incorporated a lot of the green things that you've said you're going to in the project, but it can add expense just to have to do all that paperwork. So sometimes people or organizations make the decision not to go to LEED certification, and yet their building is very green, at least as green as a LEED silver or gold building. It's just a question of, are you going to go through all that paperwork and get it actually certified? What I do is site design. A lot of people don't understand landscape architecture. If they've thought of landscape architecture at all, they tend to think of it as planting design. But the bulk of what we do is site design. And site design is the design of everything that's outside the building. The setting for the building, the utilities coming to the building, the access and the exits, the vehicular and pedestrian circulation, how you shape the ground and do the grading and drainage. All that is site design. And I decided today I wasn't going to talk a lot about traditional site design, what we need to do differently. I have a feeling that a lot of us here are fairly well educated about sustainability and green design, and we already know a lot of the bad things that are happening. What I'd like to tell you about to start is some better ways to do things, and what we might call greener site design. I don't really want to call it green site design yet because it's something that's evolving. I have a feeling in 20 years we'll look back and say, oh my gosh, the things we were doing, now we realize we should be doing them a different way. So green or greener site design, we're trying to minimize the environmental impacts of whatever development we're doing on the site and keep as much of it undamaged, the natural system still working as possible, while yet supporting human life and purposes and needs. We have to do that as well. Some of the organizations that are involved in codifying a system of greener site design right now are the U.S. Green Building Council. There's a preliminary LEED rating system out for neighborhood development, which has a lot to do with site design. Better Site Design is a paper that the New York State Department of Environmental Conservation has come out with, and they list a system of practices for developing sites in a more green way. And also the Center for Watershed Protection is a really good source of information on better site design. Their website is cwp.org, and they have lots of free information. So the start of green site design really is in your site selection. Ideally, you look for an already developed site, like the site center, that could be redeveloped for your new purpose. That's recycling already developed sites. If you can't find something like that, look for an infill site, an empty lot, or an underused area in an already developed area before you head out and develop a completely green virgin site. Go there first, and only go to a greenfield site if you really can't find anything else to fulfill the need. If you are going to develop a greenfield site, look for a site that has no habitat of imperiled species. It doesn't have really steep slopes that not only are difficult and expensive to develop, but may lead to landslides, like that top slide. When you clear the vegetation, there's a heavy rainfall, and you get tremendous and very destructive soil erosion. You want to stay off wetlands and floodplains. That's pretty well mandated by the government at this point. And also we want to protect valuable agricultural soils. We need those areas for food production and not to be compacted by equipment and paved over. So ideally you're going to look for a site, even if it's an undeveloped site, that's near existing infrastructure so that you're not extending utilities a long way and sprawling out into the undeveloped countryside. And it's better to be close in where it can be within walking distance or possibly biking distance of existing services and stores, shops, employment, maybe public transportation. Once you've picked your site, you need to take a look at it and see what's really there. Inventory it and look for what are the natural systems on the site, what are maybe the more sensitive environmental areas like steep slopes again or wetlands, and create some kind of a plan that will guide development where you've created a buffer zone around a wetland or a pond, and you've thought about things like microclimate and where can you place your buildings so that there's more chance of using solar energy or more protection from the wind. So think about the natural systems on the site first. Then you're going to place the buildings and the activity areas and the developed areas so that they have the least impact on those more sensitive areas. This particular drawing, I didn't do this. This is from a project that came before the Vestal Planning Board. And I am an alternate member on the Vestal Planning Board and was happy to see this. And I guess I should give credit. This was a project of McGowan Builders, and they gave me permission to use this sketch. They want to develop an area for housing, and part of their site is very steep and is wooded. It's that green area on the left. And so they said, we're going to preserve that. It's going to be an amenity for the neighborhood. There'll be some trails on it, but nothing else. And we'll save that as a natural area, which is obviously more than 2/3 of the site. Again, place the buildings in such a way that you can take advantage of any microclimatic differences on the site, face southeast for best solar insulation, and get some shelter around here from the winter winds if possible, which tend to come strongly from the northwest. We want to minimize the area of pavements. Pavements are bad for all kinds of reasons. Even though they're necessary, they prevent infiltration of rainfall into the ground. Water runs off very fast, causes flooding, causes more erosion, and you can't grow any plants. They won't breathe and capture carbon like a green area. So we want to minimize. One of the most important principles of site design is minimizing the impervious surfaces constructed, minimizing the area of the site that you're altering from its natural state, and then, as Laura talked about a lot, minimize the energy needed both to build it and to live in it afterwards. One way to do that is to cluster the buildings. Keep your development compact. That leaves more areas that are green and untouched. It shortens the length of utilities and drives and all those kinds of things. And that's a basic principle which is not really well accepted, especially in residential development, where everybody wants their house in the middle of their little lot and a little strip and then the next house. So cluster development is a big thing that we're hoping to move towards more and more. Also encourage alternative transportation use within the site. That means trails and bike trails within the site. There's a green spine in this project with the trail system linking the different neighborhoods. And then also you need to respond to the transportation systems and any trails, and also opportunities to get onto public transportation that are outside the site. So you need to think beyond the site that you're developing. And also allow some public green spaces that could possibly be used for local food production and community gardens. And don't make that dependent on the individual homeowner, but encourage it on a development-wide basis. The other way to minimize driveway and sidewalk pavements, besides keeping the development close together, is reduce driveway lengths. In some communities, it's mandated by a setback requirement, how far the house has to be set back from the street. Many of those requirements are greater than they need to be, and if you can reduce that, it shortens your driveway, it shortens your front walk, and also make them as narrow as you possibly can. That's another thing often mandated by the community, and something that may need change to allow, but most of our streets and sidewalks are wider than they need to be. And all those additional square feet of pavement they cost money to build, they cover over some green area, and they promote stormwater runoff and flooding. There are some alternatives to all that concrete and asphalt that are more pervious, which means it lets water soak through. There are new kinds of concrete and asphalt that are pervious. That picture on the left shows water soaking into a street in Portland, Oregon. There are also permeable pavers, where the pavers have a gap that's filled with free draining stone, and the water can drain through the pavers that way. And these are actually items, especially the pavers, that are being looked at being used more in our area. There's some questions and doubts about the pervious pavement and how it reacts in freeze-thaw. People are nervous about that, but we know that the pervious pavers with the gaps work very well in our climate. There are a lot of new stormwater management practices that involve all kinds of creative ways of letting stormwater soak in on the site and not piping it as fast as you can and sending it elsewhere to cause problems downstream. I think all of you probably have heard of green roofs, planted roofs. Those help absorb water rather than, because a roof is an impermeable surface also. Reservoirs of gravel underneath permeable pavers on the street, so that water soaks in and then is held under the surface and given time to soak into the surrounding groundwater. And in the future, especially in drier areas, there's not only the problem with excessive runoff on the surface, but there are increasing problems with, we're sending our water away rather than keeping it locally to recharge our aquifers that give us drinking water. We can reduce off-street parking. Many of the requirements in municipal codes require enough parking for everybody on Christmas Eve when they're all, doing all their last-minute Christmas shopping, and then the rest of the year the parking lot is 2/3 empty. So encouraging more shared parking between adjacent commercial properties, sharing driveways to the parking so that everybody doesn't have a drive back into their own parking lot, are additional things that help cut down on pavement. And look at your exterior lighting. Don't provide more than you need to. Not only does it cost money and energy, but it creates light pollution and sky glow. So those are some of the things that you do when you're building the actual pavements and facilities, but then when you're going to plant the project also, you can use green landscape design principles to restore the habitat that either was damaged before you got to the site, or maybe was damaged in the process of construction. And we need to use more native plantings in our landscape designs, because our native plants evolved to support the entire ecosystem. They're the foundation of the ecosystem. They bloom at the times that the pollinators are ready to seek nectar. They create the size of seed that the local birds are adapted to eat, and they're all part of the ecosystem. And native plantings are something that is becoming a really hot topic in landscape architecture, and a lot more plants are available now than there used to be. You can also use plants to manage the microclimate, shade the house on the south with deciduous trees, and create wind breaks on the northwest. Use native plants. Don't use plants that will need supplemental irrigation. All plants need some watering when they're first getting established or in a really severe drought, but don't use things that are going to require watering regularly. And don't use plants that can't survive without pesticides and herbicides, or heavy fertilizer for that matter. Another problem that creates compaction and damages nature is construction activities themselves. And it's something that we're working on, raising awareness with contractors, that heavy equipment has very long-term effects damaging the soil structure, especially in our kinds of clay soils, where for many, many, many years afterwards, that soil will not support plant growth and allow water infiltration through once it's been compacted repeatedly by driving heavy equipment around. It makes it difficult for the contractors if you make the space that they need to work in tight, but it's something that we're moving more and more towards to limit how much area of the site is driven around on or materials are stored on during construction, and trying to develop techniques to ameliorate the compaction after it has happened. These two slides are of, one is the typical construction site where everybody just drives all their equipment around everywhere, and the bottom one shows some of the erosion and sedimentation control practices and ways that you could have a construction site without it looking like a moonscape. And again, like Laura said, green design really is proving not to be more expensive than traditional design. Most studies I've seen, at worst, say that it costs the same. And at best, a lot of studies are showing that it results in a savings of 5 to 20% over conventional practices. And I've listed on this slide a few sources for some of the studies that have been done. And you can go to I guess my presentation will be on the Binghamton Sustainability website, so you can look at those later. But these savings come from basically you're building less pavement, you're clearing and grading less of the site, you're managing less stormwater runoff, you're required to build practices to manage that runoff after the project, and they're smaller. You don't have to do as much if you're not producing as much runoff. You're building fewer linear feet of curbs and gutter because we're not building curbs and gutter and sending all the water into a pipe and off-site. We're directing it to some kind of infiltration or bioretention area on the site, and you don't want a curb blocking that flow off the pavement. And you have shorter distances of utilities and piping if you're clustering development. So that's where the savings come from. It's not all savings, basically because a lot of these practices are new. When contractors bid on a job, they'll add some extra because they're not sure how long it'll take them to do the project. They haven't done it that often before. Some of the materials aren't as readily available because it hasn't been as widely used. I think those are costs that will go down with time, but right now permeable pavements cost more, and some of the new stormwater practices cost more, both to design and to build. So what's it going to take to make green site design a more normal practice? You know, I went to college 30 years ago, and many of these things were being talked about in my classes. And now we're finally getting to where I get to employ some of them. And in some ways it's incredibly disheartening, and in some ways it's actually heartening, because at least we're finally getting there. And certainly with everything that's been happening in public awareness and gas prices, it looks like we're going to get there a little faster than it seemed like we were. But there are some existing impediments out there. I alluded to some earlier. One is municipal ordinances. A lot of our existing codes actually prevent the adoption of some of these principles. Things like requiring street widths that you could land a jumbo jet on. We don't need that. People feel somehow that wider streets are safer. A lot of studies have shown that they're actually less safe because they encourage people to drive faster. So, and another question, I showed you this McGowan project for Vestal. That project's been hung up for quite a while because there's no good provision in the Vestal code for cluster development. So you have a contractor or a developer willing to try something new that's a little greener, but he's being blocked because it takes a long time to get a code change. So we need to look at our local codes and make some changes. And I've been encouraged by looking at the Center for Watershed Protection, which has put together a procedure for local governments to undertake this kind of comprehensive development code review. And I hope that we'll have some municipalities around here undertaking that and taking the lead for others to see that we can update our codes and allow and encourage more green development. Some blockages there among municipal officials. It's just normal that new things come along and you're supposed to review and approve it, and you're not familiar with it and you don't feel comfortable necessarily making a decision and approving a plan that's using some unfamiliar techniques. So it would be nice if we could encourage our towns to hire outside professionals on an hourly basis to review some and give comments on some plans that are maybe a little more unfamiliar than things they're used to seeing. Encourage our town officials to get continuing education on new and more desirable types of development. I know from my own experience that it's important to not just get the planning board educated, but also the town officials that appoint the planning board and that are ultimately responsible for everything that does get passed by the planning board. And make your municipality aware that there's a constituency out there for green design and smart growth, that you would like to see these things happen. And as always, you know, everything goes better with a little bit of sugar, and if we can talk more about how great the town could be and how wonderful these new practices are, as opposed to talking about how terrible everything is, it often goes over a little bit better. And finally, it's the developers who really are the people who are putting their money on the line, and it's hard to get people to change, especially when they're risking their own finances. Development is already an incredibly risky business, and doing things in a new and different way is more risky. So if there's some things we could do to encourage developers so that we get those first few projects that everybody can look to and say, hey, it works in our area, it's popular, it's selling, that would make such a big difference. But getting over that initial hump is so difficult. And I would really like to see municipalities find some way to provide tax incentives for green development, and also possibly some angel of a private foundation that might come up with a project and a way of funding, encouraging developers and supporting developers to try some new things, so it's not just them out on the line with their family income making this choice to do something new and different.
I'm a contractor. We do things on a practical basis, trying to make money on it as well as make it work in the environment. And sometimes we find out that the ideas are not, the consumers don't want it enough to make it worthwhile to do it right now. And when that happens, we have to, where is it? Come on, open up. When it happens, we have to decide in our mind, oh, you know, it's not going to work, Joe. Oh, well. We have to decide if we can make these things work or not in the market. Sometimes you can't. And when you can't, you just wing it. You go out and you sell something you can sell. Fiberglass is a very easy product to get. It doesn't always work well because you can't put it in right. You have centers that are off center. You have Cape Cod style houses that don't have a side on one side of the wall. You have things that don't support fiberglass. This fiberglass needs to be in an airtight space. It's sort of like fleece. When you wear fleece outside and it's still air, you feel warm. But if you're in any kind of a wind or a draft, you lose that comfort. It gets cold. And to make that system work, you put on a Gore-Tex jacket. Well, if the Gore-Tex jacket is too tight or too small, you're not warm, you're cold. If it's not Gore-Tex, it's rubber, it gets wet inside of there, you get wet, you don't stay warm. Making a building perform is much similar to that. You've got to find a way to let the building breathe enough, but not too much. You got to be able to put in a conductive barrier so that you're comfortable and warm. And that conductive barrier can be a lot of different products. She showed some cotton bats. I never saw them in the marketplace. I don't know where you can get them even, but sure, they'd work. A lot of cellulose will work too. That's ground up newspaper. So will foam. And you talked about soy foam. Soy foam, it's a funny product. There are guys who will tell you their product is all soy, and it can't be, because urethane has always been a hardener in a resin system, and the hardener side is the same. So 50% of your product is not soy, at least. And some of the soy resins are, very minimal soy, and some are a lot of soy. It depends on the product, and the manufacturers are not going to send out information to the market and say this is what we're using, because it's proprietary. They don't really want you to know how much they're using, and because they can't be using 100%. So some of that's greenwashing, some of that's marketing, but there are applications where foam is the best thing going, because it has high embodied energy, yes, but the energy it saves over the course of the building is so big, and it makes the building so durable because you don't have vapor issues, you don't have air barrier issues with foam, that the buildings work better. But there are places where foam is overkill. If you're building a conventional building with 2x6 walls, and you've got the space, and you've got wide open 16-inch wide cavities that are easy to insulate, put cellulose in there, put cotton in there, whatever you want in those cavities. But if you have your floor sitting on top of your basement, there's little squares up there, they're very hard to insulate anyway, right? Well, use foam there. The trick is to find a contractor who's advanced enough to offer all these systems together, and open-minded enough to try things that maybe he hasn't tried before. And it's hard to find those guys. And also, like they said earlier today, I think it was that lady on the end down there, about the shell guys going to a house to analyze a retrofit house and saying, you need insulation and that's all you need. That's not all you need. I've had 3 jobs this week that I lost because I go in the basement and I find a boiler that doesn't vent right, or a heating system that's got a problem with the heat exchanger. In one house I couldn't believe it, I found 2 water heaters that were side by side, and they're both gas fired, and somebody must have told the people, when you only have one chimney, hook them together, because they did, they hooked them one to the other, no pipe to the outside. But you can't make that house tight, you can't make that house seal up with that situation, because you're going to kill somebody. But you see it, If you get into this business and you're out looking at houses, you'll find that kind of thing. I did work on John's house here, and I think Adam's had done estimates for him. I'm not sure who else is around here that I've worked for, but okay. I mean, there's been a lot out there. It's a shame that right in this room right now there's no builders that I can see. I don't think there's any builders in here right now. I don't see a whole lot of other contractors. I know John's starting into contracting, but there's not a lot of other contractors around out here right now. Louis is a consultant to contractors, I believe, right? But isn't it kind of odd there's no contractors here? That's the reason there's not, is because in the market today, there's perception in the business end of it, in the contracting end, that this has not got a great big jump and a big push. And until it does, until the consumers start demanding it, contractors won't supply it. We're a pretty conservative bunch. We want to make money whatever we do. And there are times that you just can't be that far ahead of the curve. But the curve is getting there. The people are starting to want it more, and I'm really kind of curious about questions from you guys to see what kinds of things you want to know, to see if, even if I can adapt a little bit to make it so that they can service what you want. And the contractors will come if you create the market. They're going to have to. It's harder and harder to find a house to start right now, and the green, what is it, Patterson's idea of a green building now, that they have the incentives out there for building green, or $7,500 to $15,000 on a house, right? And they're saying that the house has to be completed by December 2010, and you have to start planning it before the hole in the ground. There should be a committee, a green person, a green verifier, or a green rater, or somebody like that, a builder, consumer, an architect. And I didn't know you had landscape architects, but that's a great idea, because they're picking site design. You get all those people together before you start. You get points for that. It's just a practical thing to do. But the consumers need to start asking for it, and the marketing seems to come out there to start telling the consumers to ask for it. I think that's where it's got to start.
For Madeleine, I wonder if there isn't some sociology behind your cluster development. Why do you talk about houses with undeveloped space and then talk about a space someplace else for community gardens? You know, the model that I know about for people who garden seriously and produce a lot of their own food is invariably the backyard garden. And you seem to have some other design in mind, and quite frankly, this, in my mind, this brings up probably an irrational prejudice I have about suburban developments where nobody ever grows a vegetable in their backyard. Not that there's a law against it, apparently it offends the other people. I mean, if you drive around the stair tract and see how many tomatoes you see, okay? And so it seems to me that's kind of repeating that model, and then, well, we'll put a community garden someplace. What's behind your
I think it
thinking
depends
here?
on how tightly you're clustered. If you're clustered so tightly that you don't really have room for a garden, then down at the end of your block, there's space for people to have communal gardens. I don't mean you're driving to the communal garden, but something where there's enough room and also possibly encouragement and experience of other gardeners, so that it becomes a more social thing with support of experienced gardeners to inexperienced gardeners.